Hello friends, welcome back to your channel. So in this channel we try to solve the previous year's question papers of physics for NEET undergrad exam which are held in India. This will also be helpful for those students who are appearing for JEE mains as these are NCERT related questions. We have made all attempts to solve this in a very student friendly manner so that you can easily understand the concepts and you'll be able to follow it going forward. We have tried our best to solve the different types of questions which appear in the earlier year's question papers so that you don't miss them. We hope you are able to follow the solutions easily. If you still have doubts, then please feel free to add in the comment section and we will revert to you at the earliest possible. So without much ado, let's start solving the problems. So earlier we had given you some problems on friction. So in this session, we'll be trying to solve these problems on friction. Okay. So the very first question is like this. So before that, right, I hope all of you know what friction is, but just to give you basic understanding, what is friction, right? Then give you a basic understanding of friction. So what is friction? For example, imagine that there is a body here. Okay, imagine there's a body here which is trying to move here. So the friction will oppose this motion here. Okay, friction will oppose this motion, and what will be the magnitude of the friction, which will be mu times the normal reaction. Okay, so if this is a normal reaction, what is a normal reaction? It is basically the force acting on this body, right? The force acting by the body on the surface. Okay, this is also equal to N for equilibrium. Okay, so N in this case, right, if the mass of the body is M, so N will be equal to mg. Okay, so then what is the frictional force in this case? Frictional force will be equal to mass into g into a coefficient of friction, which is mu. Okay, this we can write it as mg. Okay, now what trick here, like when we are walking, have you ever thought that in which direction is the friction working? So for example, when a person is walking, right, when a person is walking like this, right, is walking like this in the forward direction. Okay, have you ever thought that which direction the friction is working? Is it working in the forward direction or in the backward direction? Have you ever thought about this? So contrary to popular belief, right, the friction is not. So when you're putting your feet on the floor, so basically friction, which is the one which will actually help you propel forward direction. Okay, so friction is not acting like this here. Friction is like acting like this. Okay, so this just I wanted to let you know, because this is a very common thing which people make mistakes. So coming back to the problem now, there is one more thing which before we move forward, right? There one more concept called the static friction and the kinetic friction. It will not be required for this problem, but I think it will be worth knowing what is static friction and what is kinetic friction. So what is static friction? As the name suggests, right? When the body is static, when the body is not moving, the friction which is acting on it is called a static friction. And kinetic motion, we all know it's all about motion, right? So kinetic friction is when the body is already moving, the friction acting on the body, it's called the kinetic friction. So now let's take this example here. So if P is not moving, right, if P is static, and there's an equilibrium between P and Q, so that none of them is moving. So what is the friction on this? This will be the static friction, right? But the moment P starts moving, then there'll be another kind of friction will be acting on this. It will not be static friction anymore. When the body or block P starts moving, then the kinetic sorry then the kinetic friction will start acting on the body. Okay, and static is always static, the initial friction, right, it is always more than the kinetic friction. Okay, now coming back to the problem now. Okay, coming back to the problem. So here we are given two blocks P and Q, and they are not moving. So it means if they are not moving means there is an equilibrium, right? So there is an equilibrium. There is a tension T acting on this rope here. There is a tension T acting on this rope here. Okay. Now what is the if the value, if the mass of Q is m, then the gravitational force on Q will be mg. Okay. And what about the friction force here? So the friction force, so if this body tries to move, in this direction, right? So now which way will the friction act? The friction will act against this, right? The friction will act against the motion of the body. Okay. And what will be the magnitude of the friction? We just discussed now, right? That what is the weight of this one, which is acting on the surface with mg. Mg is the weight of the body acting on the surface. So what will be the normal reaction? N for equilibrium, N is equal to mg. Okay. So then what will be the frictional force? Friction force, as we said, it is acting in this direction, right? It is acting in this direction. Okay. So frictional force is equal to mu m g in this case. Okay. So please remember, this is very important formula. Frictional force is equal to mu mg for such scenarios. Okay. So now coming back to solving the problem. Coming to solving the problem here. So in this case it is given, so let's take this the two blocks individually, right? So this block is here. Okay, this block, there is a tension T acting on it. What is the mass? The mass of this block is given to be 2 kg, right? 2 kg. Okay, fine. So what is the tension T? If there is an equilibrium here, then T is equal to T is equal to the frictional force on this body, right? So why 2? Because 2 is the mass of this body, and then 10, which is the accelerating gravity, into mu. The mu is given to be 0.2 in this question. So this is equal to 20 into 0.2. This is equal to 4 newtons. Okay. So this is the tension on this, tension on the rope. Okay, which is going through pulley. Let's look at the other part of the pulley. Other part of the pulley is like this, right? Which is hanging here, which is supporting this block here. Okay. Now what is the mass here? Say m. Okay, and it is g, which is the gravitational pull. So the weight of the body is equal to mg. For equilibrium, this will also be equal to T, right? So then T is equal to mg. Okay, or we can write it that this is equal to 10 m. Okay. So for equilibrium, we can say that this T is equivalent to this T, right? Because it is not moving. Okay, and the T is the same. So we can say that 10 m is equal to 4. Then m that the mass of Q is equal to 4 by 10 is equal to 0.4. 0.4 kg. Okay, this is the answer. Okay, let's move to the next question now. In this question, it's given that there is chain here, which you can see here, there is chain here. Okay, the chain hanging here, partly hanging and partly it's on the table. So now what will happen? Imagine that if there is no friction, fortunately there is a friction acting on this, right? So so what will be the direction of friction then? So the chain which is there, the chain is being stopped to fall, right? It means so there is a friction acting on the chain in the reverse direction, correct? In the reverse direction on the surface of the table. So this will be on the surface of the table, right? So it will be acting in the reverse direction. It is not allowing the chain to fall from the table, right? So but we know that to calculate this friction, we need the mass, right? The mass is not given here, but what is given, what we know is that there is a length of the chain, right? So imagine the total length of the chain. Total length is equal to L, okay? And this is X part is actually hanging outside and the remaining part is L minus X, okay? So L minus X is on the table and X is the part which is hanging outside the table, right? So now what will be the frictional force on this? Frictional force will act only on the part which is there on the table, right? Only on this part, right? Frictional force will not act on this part of the chain, right? Friction force will act only on the part of the body or part of the chain which is on the table. So now imagine that now mass is, this is uniform chain, right? So it means mass has to be proportional to L. Mass is to be proportional to L. So imagine that mass is equal to KL. Okay, mass is equal to KL. Okay. So the mass of the part of the chain on the table is equal to, so the table portion chain mass equal to K into L minus X, okay? And the hanging portion mass is equal to Kx, right? So what will be the frictional force on this? Frictional force will be acting on the table portion, right? So frictional force will be acting on this. So if this is the mass, then the frictional force will be mu into the mass L into G, okay? And this will have only the gravitational force, right? So Kx, the gravitational force is equal to gravitational force is equal to Kx into G. Now, since they are in equilibrium, it means there is no movement, right? So it means then this part, that is the frictional force, is equal to the gravitational force of this part, right? It means mu K L minus X G equal to Kx G, okay? So now we start cancelling them. Means mu L minus mu X is equal to X. Okay. Now it is given that mu is equal to 0.2. Okay. So it means 0.2 L minus 0.2 X is equal to X. It means 0.2 L is equal to 1.2 X. Meaning X is equal to 0.2 L divided by 1.2 L by 6. Okay, so it means this portion of the chain is equal to L by 6, and the rest of it is equal to 5 L by, how did you get 5 L by 6 is equal to 1 minus 1 by 6, okay, right? So this part is a chain on top of the table. So it means the hanging part is only L by 6. This is equal to 1 by 6 is roughly 1 by 6 is roughly 16.67%. Roughly I can say it is 17%. Okay. So the answer given here. So out of the given answers, I think the best answer would be 17%. Okay. Let's move to the next problem now. A block is pushed momentarily along a horizontal surface with a velocity v. So it means there is a block lying on the table. So we are pushing this with a velocity v. Now what will happen here? So since there is a friction, so as it tries to move forward, then the friction will try to prevent the motion. Okay, this is friction F, which will prevent the motion. Okay, and this is the velocity v, which we are trying to push the block, and this is the block we are talking about. This is a block. This is a block. Okay, great. So what is the frictional force on this? What is the frictional force on this? Okay, the frictional force will be equal to, if the block has a mass of m, then this will be mg, will be the weight, and the normal reaction of this will n, okay, is equal to, let me just change the color here so it becomes easy to understand. So n is equal to mg, right? N is equal to mg. So then frictional force is equal to, frictional force is equal to mu m. So friction force is equal to mu m g. Okay. Now we are trying to push a velocity with velocity v, and this frictional force will actually cause a deceleration, right? Which will cause a negative acceleration for this body, which is moving at a velocity v. And what will be the negative acceleration? So negative acceleration is also called a deceleration, equal to force upon mass, is equal to mu m g upon m, is equal to mu g. So this is the deceleration of the body which is trying to move forward. Okay, so we need to find out that in what time we come to rest. So we have those three key formula, if you remember, right? Which we learned from straight line motion also, which is v is equal to u plus at, s is equal to ut plus half at square, and the third one is v square is equal to u square plus 2a. So in this case, we will try to apply the formula v is equal to u plus at. What is v? This is the final velocity, which will be 0 in this case, right? Because it is trying to move forward the frictional force, which is causing a deceleration, which will eventually stop the mass, okay, at some point in time. So mass, if it's starting here, at some point in time here, right, somewhere here, it will actually stop. Okay, well, v will become 0. Okay, so v is equal to 0. Finally, u is the initial velocity which is given a v. T is the t is what we need to find here. Okay, and a is known to us the deceleration here. Okay, so we need to find a t. So t is equal to u by a. Okay, I'm not giving a negative sign here because a is the deceleration here, which is a negative acceleration. Okay, so this is equal to, so we know that u is equal to v, and the negative acceleration a is equal to mu g. Okay, it means t is equal to v by mu g. So the answer is given here. So answer is, one of the answers is given here is that t is equal to mu V by, this is the answer here. Okay, let's go to the next problem now. Okay, an aluminum horizontal plate. So now this is aluminum horizontal plate here. Now, as long as it is horizontal, it is not moving because there is a friction which is acting on this, right? So because of friction, will the body move? The body will not move. The body will remain static there. Okay, so in this case, if the body tries to move in this direction, then the frictional force is here, which are not allowed to move, right? So frictional force, the friction is acting in the reverse direction of the motion. Okay, but eventually, if we tilt it like this, right? If you tilt it like this, okay, if you tilt it like this, then what will happen is that you tilt it like this, then the body will try to move downwards. Body will try to move downwards, though there will be a friction force acting on the body. So friction force will still act on this body here, right? In this direction. Still act in this direction, but it will not be able to move forward. It will be prevented from motion by the friction. Okay. But at some point in time, if you keep inclining it further and further, right? If you keep moving further and further, at some point in time, the block will start moving. Okay. So now this is given to us to be a theta. Okay. Now let's look at the forces which are acting on this block here. Okay. So what are the forces acting on this block now? So the forces acting on the block are so the forces acting on the block is, so this is the block here. So this will be mg. This will be mg, which is the force acting here. Okay. So if this is theta, then this has got to be 90 minus theta. Okay. So 90 minus theta, and this will, then in that case, if this is a right angle, then this will be theta. Okay. So if this is mg, then this will become mg cos theta. Correct. And then what will this become? This is the mg sin theta. What is this force going to do? This force is allowing the block to slide across the inclined plane. Okay. What is normal reaction on this? The normal reaction on this. So normal reaction is n here, and this will be mg cos theta. Okay, because what is the force on this? Active force of the block or weight of the block acting on the body, it will be mg cos theta. Okay, so it means n is equal to mg cos theta. Okay, it means what is the frictional force? Friction is equal to mu m g cos theta. Okay, friction is equal to mu mg cos theta, and along the plane, the acceleration, the force along the plane, the gravitational force along the plane, along incline, should I say, is equal to m g sin theta. Okay, which we've already told you, right? We mentioned mg sin theta. Okay, right? So this is mg sin theta, and this is mg cos theta. Okay, so we need to find both kinds of friction, which is the static friction and the kinetic friction. Now, earlier, if you remember at the beginning of friction, we discussed about static friction and kinetic friction. I will just give a recap of that. Static friction is the friction acting on a body which is static, which is not moving. So here in this case, here in this case, when the body was not moving at all, right here, the body was not moving. At this scenario, when this was not moving at all, then this is the static friction. Okay, correct. So now when it is not moving, then this friction is equal to this one, correct? So it means mu mg cos theta equal to mg sin theta. Okay, so mg gone here, means mu is equal to tan theta. Okay, now this will be the static friction, right? Because the body is still not moving in equilibrium. Okay, so I'm just denoting it by S. So if theta is equal to 60 degrees, which is given in the problem, right? It's given to be 60 degrees here. Means then mu S is equal to tan of 60 degrees is equal to root 3 is equal to 1.7. The first part is known to be mu S is equal to 1.732. Okay. The first part of the problem, we have been able to solve this. Is mu is equal to 1.732. Okay. So mu static mu is equal to 1.732. Okay. Right. What about the kinetic friction now, right? Kinetic friction will be applicable when the body starts moving. Now, when the body is moving, it will be moving in this direction with the acceleration of a. Okay, so I can write here ma is equal to the sliding force is the gravitational force mg sin theta minus mu mg cos theta. What is this one? This is a frictional force, right? The frictional force. Okay, so it means I can write here A is equal to g sin theta minus mu g cos theta. Okay, now we have all the values here. G is given to be 10, sin theta is root 3 by 2, which sin 60 degrees, minus mu is to be known here. Okay, minus mu into 10 into half. Okay, then 5 root 3 minus this will be 5 mu. This will be a. Okay, so this is one part of the question, one part of the solution, correct? So now when it is given to us that this in the question, if you have noticed, we have been given that it is moving, it moves 5 meters down in the plate in 5 seconds. Okay, so what will be the acceleration in that case? We need to find the acceleration here, right? So we know that S is equal to ut plus half a t square. Okay, is half at square. Since it started from rest, u is equal to 0, it means S is equal to half into a into t square. T is given that in 5 seconds, right? In the problem, 5 seconds, it is 5 square, and S is given to be 5, right? It means A is equal to 5 into 2 divided by 5 to 2. A is equal to 5 into 2. S is equal to ut plus half at square. So 5 is equal to half into a into 5 square. Okay. So if we solve this problem, if we solve this, then then A is equal to 2 into 5 divided by 5 square, which is equal to 10 divided by 25 is equal to 0.4. Okay, so A is equal to 0.4. Now we need to substitute in this thing, right? So it means 0.4 is equal to 5 root 3 minus 5 mu. Okay, so 0.4 is equal to 5 into root 3 is 8.66 minus 5 mu. Okay, so 5 mu is equal to 8.66 minus 4. This is equal to 8.26. Okay, thereafter that means mu is equal to 8.26 divided by 5. So this will be roughly 1.65 roughly. Okay, what is this? This is a kinetic friction. Why kinetic friction? Because the body has already started moving. Okay, right? So the answer should be, this is the closest answer which you have here out of the given question. This is the closest answer which you will have here. This will be the answer. Okay.
So now we go to question number 5. As per this problem, you can see that there is a block here. This block here at the top of an incline. Now imagine if there is no friction here, what will happen is that the block will have a tendency to fall along the incline, right? So in this problem, it is given that the half of it, right? So imagine that this total length is 2L. So L length is given to be having friction, and the balance part of it, right, which is the balance L part, it does not have any friction. So there is no friction here, but there is only friction here, right? So imagine that if there is friction here, then what will happen is that once the block is sliding and the moment it crosses this point, then it will face a resistance from here, right? It will face a resistance from this side. It will face a resistance from this side for its motion, right? So this is what will happen, right? So now let's go back to this now. Now imagine if this angle is theta, right? If this angle is theta, then we have seen in our previous problem that one minute please. So if the angle is theta here, if this angle is theta, then we have seen in our previous problem that, so what happens is that, so this is G, right? This is G. This is G. This is 90 minus theta, because this is a right angle, right? This is a right angle here. And this is, again, this is theta. So the 90 minus theta, so the component of the gravity along this plane will be G sine theta, right? And the component of G along this will be G cos theta. Okay, so now when the block will fall, so what will be the acceleration now? If it is normally falls like this, right? So we will say it is G, but when it's falling along the incline like this, then the acceleration will be equal to G sine theta, right? G sine theta. Okay, also we know that this length is L, right? As we said earlier, that this length is L, this length is L here, and the top part, this length is also L. Okay, so we know that V square is equal to U square plus 2AS. Now this is a one formula which you know from straight line motion since the initial days, right? What is V here? V is the final velocity, U is the initial velocity, A is the acceleration, and S is the distance covered. So if you look at this particular thing here, when it starts from the top here and it traverses a length L, when it traverses length L, so let's look at the velocity at this point, right? What will be the velocity at this point? That is what we need to, capture, right? So we need to capture the velocity at this point, right? What will be the velocity at this point when the block is starting from here and reaching here? Okay, so this is the velocity which will capture. Imagine that this point we name it as, say, for example, B, right? Imagine if we name this point as B, so V at B, V square is equal to 0 plus 2a. What is the acceleration? Acceleration is g sine theta, right? Which is g sine theta into the length traverse, which is L, right? So Vb square, the velocity at Vb square is equal to 2g L sine theta. Okay, so this is the velocity at B. So this is what we arrived at till now. Okay, now having arrived at this, now we need to look at the other part of L, right? Now in this part, right, when this part the block is falling, there is a friction here, right? And from the previous problem you have noticed that when it falls on an incline, the MA is equal to mg sine theta. Now this is, if the friction is not there, you know that the acceleration is the force is mg sine theta, right? But if there is a friction, then what happens, that it is actually minus mu mg cos theta. Okay, so it means the acceleration is basically equal to g sine theta minus mu g cos theta. Okay, this is in when the friction is there, right? This is friction is there, and this is when friction is not there. When friction is not there. Okay, so now we know that v square is equal to u square plus 2s. Now let's look at the block. Actually, when it falls here, it falls here and it comes to rest. So it means, imagine, let's look at this particular part of it only. Then let's look at this part only, right? Correct. Let me erase the other part of it so as to make it easy for you to understand. Okay. Yeah. So the block is falling like this. The block is falling like this. It traverses a distance L from here to here. So again, we can use the formula v square is equal to u square plus 2as. We can use the same formula here, right? In this case, because of this acceleration, this is the acceleration here, which is a new acceleration. The v is the final velocity when it lands here, right? So which is equal to 0, correct? Is equal to u square. Now what is the velocity at this point, which is nothing but equal to vb? Okay, vb, which we calculated 2gl sine theta, right, is equal to 2gl sine theta. Okay, v square is equal to 2gl sine theta. That's what is substituted, plus 2. Now what is the acceleration? Now we have seen that what is the acceleration when friction is applicable? It is g sine theta minus mu g cos theta. It is g sine theta minus mu g cos theta. Now v square is equal to this thing, so this is equal to the 2a and s. This is L, right? Because it's traversing a distance of L here. So now, so it means that, so we can just cut the common things here. So g is common across everywhere, which you can remove g from here. We have L, which is common everywhere, so we can remove L here, correct? So now we're left with 2 sine theta plus again 2 into sine theta, right? 2 sine theta once again minus 2 mu cos theta, right? 2 mu cos theta, right? It means 4. Okay, plus 2 sine theta. So this is equal to, okay, 2 minus 2 plus 4. Yeah, is equal to, it means 4 sine theta minus 2 mu cos theta is equal to 0. Okay, so that means 4 sine theta is equal to 2 mu cos theta. Okay, means mu is equal to 4 sine theta upon 2 cos theta. This is equal to 2 tan theta. Okay, so it means the answer is mu is equal to 2 tan theta. Okay, so the answer will be, here. So the answer in this case will be the B one, the B. Okay, so friends, we solved the first 5 problems in this video. I hope you like the approach how we solve it. I hope it will be really helpful for you. We will request you that if you are liking these videos and if it is helping you, you please drop in your comments, and you can like the videos. You can also subscribe to this channel, because we'll be working, we'll be helping you with the previous year questions of NEET physics. Okay, we'll request you once again to like and subscribe the channel. So in the next video, we'll solve the next question, which is from question number 6 onwards of this exercise. Okay, thank you very much. We hope you log in once again. Thank you.